Am I audible, sir?
Yes, you are audible.
Okay. Just a
You
moment.
can start the session.
Okay. Is everyone there, sir?
Hello, sir, Robin. Sir, you are not audible.
Yeah. Are people joining, sir? Yes, sir. Are the people joining? Just a moment. Am I audible and visible clearly, sir?
Sir. Okay, you can start now.
Okay. Yes, sir. So I'll be sharing my screen from this side. Okay. Is my screen visible, sir?
Yes, yes.
Okay. So can we make it a interactive session? Like, can people interact with me?
Yes, sir.
Yeah. Okay. So before starting, can anyone like give me overview that what are have you been doing till now in the rocket motor things?
Sir, we prepared.
Any-
Hello.
Yeah, please.
Sir, till now we designed a rocket model and we
Okay.
prepared rocket fuel, sir. Solid fuel.
Okay. You guys have made the mixtures and in the right proportion.
Yes, sir, 65 30.
Okay. What are the constituents? Hello.
No, sir. And,
Can you please tell me the constituents that you have been using in those motors? You guys have made some motors like these, right?
yes, sir.
Yeah. Like over here, I have a. uh, This is the F category. You guys might be knowing about the categories.
Yes, sir.
Yeah, are you
B,
guys familiar? Huh?
A, B, C, D.
Yeah. And and do you guys know have specified that which category are you guys using?
B, sir. B, sir.
B. Okay. What's the size? What's the length? Length.
12 centimeter.
How much?
12 centimeters, sir.
12 centimeters. Okay. So here's a guide. Like I'll be sharing this PDF with you guys too. Like I just wanted to give some a little overview that about the motors that you guys have been using. So have you guys done any calculations about the thrust or something that you guys might be getting out of it?
No, sir.
Okay, no worries. Okay, this guide might be helpful for you. So, chemicals, all done. Can you convert that 12 centimeters into inches for me?
120 inches.
How much?
ಇಲ್ಲ ಇಲ್ಲ ಸಾರಿ 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 4 inches
4 inches. Okay.
4.5 sir
Hmm? 4 point?
4.5 inches
4.5 inches. Then 4.5 inches, it does not sound like a B. 4.5 inches does not sound like a B motor. It sounds like something E. Yeah. Because over here I am having a F7 motor. So it is 5 inches.
yes, sir.
B is not that. Okay, we'll see. So you guys have stacked it? Have you guys stacked it with the clay and the white mix?
Yes, sir.
Okay. Can you explain me that how have you done that thing? Yeah, I saw that video of you guys doing some stuff. Yeah, that was great.
Thank
Can
you,
you
sir.
guys just let me know that how you guys did it actually?
Sir, we used PVC pipe as a
PVC pipe. Okay.
capsule and we used the MCL to seal the bottom.
How what? MSIL?
Yes, sir.
Yeah, great, great. Nice. Okay, I have got two motors over there. One in this one we have used MSIL.
Yes, sir. Both on the sides.
Yeah. Okay, you guys used MSIL, right? Okay. From both sides for the seal and the plug both.
Yes, sir. We used to both sides.
Yeah.
Use.
This side is known as the plug and this side is known as the seal or the nozzle. Okay. The open end that we ignite is known as nozzle, and the other one is the plug.
Yes,
Okay.
sir.
How much? Can you tell me like how much have you kept the M seal part like in this much? Do you guys have that motor with you right now?
Motor.
Yeah, I want this session to be a little interactive so that I might be learning something from you and you guys might be learning something from me. As being arrow people, we need to effort needs to be mutual. It's not just me telling you anything. Oh, great. Nice to see you guys. Just a moment.
This side, sir.
Great. A little lower, yeah. Side view. Okay. This is the seal side, right?
What, sir?
Okay. Can you show me the nozzle side?
Okay.
How have you kept it? Nozzle. Great. Great. Have you did it like how have you drilled the hole inside the core?
Using
Did you use some drill?
drill bit.
Okay, great, great work. You guys have done great work. Like we have also done these things, and this one we have sealed using M seal plus Fuller's. Like over here, while we were making, we used Fuller's Earth. Have you guys? Are you guys familiar with Fuller's Earth? This clay soil that girls used to apply on their faces also. Yeah, face packs. You guys familiar with that?
Oh, yes, sir.
Fuller's Earth, yeah. Okay. It is known as Multani Mitti or something, right? Okay. So we stacked it with that. So MCL is a good option because plug should not come off. If it comes off, then your motor is of no use. Okay. Have you tested one of these?
No, sir.
Not yet. Okay. So today I'll be showing you that how to make a homemade igniter so that you guys can make it anywhere and apply your test your rocket motors anywhere. You guys make a plenty of it. Okay, keep testing this. So it's not a thing. I'll show you one interesting thing. I've got two rockets over there. This is the size of the rocket in which we are using. This is a 50 centimeter rocket, so which we are using this F7 motor. Okay, so I just giving you a reference that where we are being using these things. So we have been flying a lot of it. Like, wait, I'll show you one. Is my screen visible?
Yes, sir.
Okay. Can you guys see this? This is when we tested this motor, and it was giving us a thrust of nearly 8 to 9 newtons, or nearly 7 to 10 newtons. Okay, that was the thrust that this motor, homemade motor, was giving us. Okay, so I hope that the like, can you tell me the in grams, what's the amount of fuel that you have filled into it?
40 grams.
How much?
40 grams. Totally 40 grams, sir.
40 grams. Okay. And I guess some of it came out when you drilled it, right?
Yes, sir.
So you can say we are having nearly 35 to 40 grams of fuel inside, right?
Yes, sir.
Okay. So it is surely nearly a D motor. So you can guys can't say that it's a B1. It's nearly a D.
Okay, sir.
Okay, according to my references. So this igniter that I wanted to show you was like, it was a simple homemade thing. What we used was, can you guys see this?
Yes, sir.
Sorry. Hello?
Yes, sir. Yes, sir.
Okay.
You see them.
Isn't it? Oh, huh, yeah. They are. Can you see the ignition?
Yes, sir. Yes, sir.
It's a simple thing. Like, what we did here. We did a lot of it. Oh, what we. Yeah. So can you guys see this? Okay. Now maybe more will better, right? So what I over here, what we use was like just a matchstick. You guys might be having matchstick over there. Find one, and a cup and a 1 meter wire. We bought that, a simple wire that needs to be having very thin copper inside. Okay, if you guys see it,
Yes, sir.
just come on. Oh, where it went? It needs to be having a very thin copper. And what you guys need to do is like burn a matchstick. Take the wire like whatever length you want suitable. Okay. But here, we have made a remote control one also. But first of all, we need to learn about the simplicity. Okay, guys, getting me?
Yes, sir. Yes, sir.
Okay. So what we did over here was that we took a wire and doubled it. Suppose I want this much length. This is safe, I guess. This much length would be safe. I'll be this much far from the launching site. Okay.
Yes, sir.
What we did was just take this portion and take a matchstick and burn it. Burn the insulation. Okay. Burn it enough so just so that the insulation may come off. Okay. We require the wire inside, okay? It's a simple thing. You guys can do it there, right?
I think so, sir.
What?
Think so.
Think so? Yeah, you guys are arrow people. I think enough. You guys can do these things, yeah.
What?
Yeah. Okay. Can you guys see this? The insulation is removed,
Yes, sir.
right? So what we're gonna do is like over here I can see that there are plenty of wires like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 strands over there inside, okay? So you just need two of them. You have to cut the rest of the eight. Okay. Rest of the eight you need to disconnect and you just need to keep just two
Okay,
because
sir.
two is enough for ignition, okay? Because if you kept those 10 of those, so you won't be having that much ignition temperature for the matchstick to light, okay? So for the ignition, what we do is we separate two of them. Just take a pair of pliers. Where the other guys went? Hmm?
Here you, sir.
Are they here only? Okay, okay. You guys there only. So if you guys can see it, I have separated two and the other eight. Okay,
Okay, sir.
is it okay? It's a simple. Just take pliers. Just cut the eight. Oh my God, not working. This is the only junction that you require. Okay,
Yes, sir.
you
Sir.
get these two wires connected.
Yes, sir.
Can you see it? Okay.
Yes, sir. Yes, sir.
Just simple as that. Right? So what you guys should do over here is take, take the take the matchstick that you have were having. Take one out. Okay. Now here's the matchstick, and just tightly hung blade and make a slight mark, like just to house the. Can you guys see what I'm doing? What I did over here? Just rub it on it, and so that you can house your wire. The igniter wire should not fall off. Okay, because when you will be inserting it inside, then the wire will be displaced for sure. And if it is displaced, then igniter won't be working. Now, what's the next step is that you take that wire, it, where it went here. Sorry, it's a mess around here. So just take this matchstick and place it between the wire. Are you guys able to get it? Wait. Wait. Getting it?
Yes, sir.
Okay. Simple.
Yes, sir. Yes, sir.
Okay. Sorry. Okay. So I have one made over. This is a simple process now. Then you guys can tape it and make it into place. Okay. And make sure that it should not exceed the diameter of your core. You guys know what core is? Can anyone define what core of a solid motor is?
Fuels. No, center.
Hmm?
The center point of the motor is
Yeah. The central surface area. Okay. The inner surface area of the propellant that is to be burnt.
Yes, sir.
Okay. Now I have one igniter ready over here. This is one of my friends made this one. So it would be working here. Okay. So I've got the wires connected and I'll take a battery over here. Simple Duracell would be working. So over here, just connect both the ends to the battery. Can you guys see it? Is it clear?
Yes, sir. Yes, sir.
Can you see how I taped it? Like,
Yes, sir. Yes, sir.
yeah, I taped it so that it can go inside the core very well. Okay. Without very cautious while playing with fire. We got our hands burned many times. So I'm going to like just oh, told you if wire is not connected properly, it's not on the ignition part, then it want to be ignited. No way here it's not. I need to change the matchstick, I guess. Great. Some of the wires are connected on the lower side. Last time we did it with a 3-volt battery. This time I'm trying it with 1.5. Let's see if it ignites. Oh, it needs more current. Okay, we'll be giving it more current. Come on, yaar, ignite. We'll make another one. Like these igniters have been here for like weeks now. That's why they're not working, I guess. Which rocket body are you using here? The rocket tube, can I see it?
Yes, sir.
Wait. Can you show me? Okay. When are you guys planning to test it? The motor, the rocket launching? Hmm? Wednesday?
No,
Tomorrow?
tomorrow. Yes.
Okay. I remember we were there, we also tested it and it was great success.
Okay, sir.
In Tirunelveli was it's the place where I tested our first rocket model. So from there we got into this rocketry and other things, and then we conducted competitions over here, and it was a great success. So I hope that this thing ignites the aero modeler inside you, and you guys make more models, more powerful models.
Thank you, sir.
Let me strip it. Should keep smaller distance. Which courses are like aerospace engineering, right? Or aeronautical?
Aerospace engineering.
Which semester?
Fifth semester.
Fifth semester. Great. Fifth completed. Now in sixth. Okay, must be third years. Okay. College.
Lakshmi Srinivasan Engineering College.
Okay, great. So let's try if it happens. Actually, the cells that we were using were really batteries were powerful. You can see on the screen too. These are the batteries that we were using. It was giving us nearly 1.5 volt over here. And let's see if it runs. No, 1.5 volt is less. I'm just glad. Why isn't it? Actually, the other project people took the things from here, and I was really unaware till the morning that the proper stuff isn't here. Now, let's see if it ignites with three. What kind of cells are you guys having? Like batteries?
Yes, sir.
Like I was asking about the availability. What kind of batteries do you have over there, or can make?
9 volt. We can use 9 volt batteries.
Hmm?
9 volt batteries.
9
9 volt.
volt. Ah, that would be fine. Anything above 5 would be fine.
Okay, sir.
We thought that they would also work. I think with the battery, I guess. Let me test if it works. Okay. Oh, I don't know what is up with this now. What's working? We've burnt many with these. Chalo, never mind. Sorry for this. You guys can see in the video itself that it is working, and you guys can make it like that. Now I wanted to share one more thing with you. That was, are you guys interested in making it like radio controlled? That you can control it from 10 feet, 5 feet.
Yes, yes, sir.
Yeah. Okay. Are you guys familiar with IoT, Internet of Things? Any one of you?
Little bit, sir. Little bit. Yeah. Little bit. We don't have hands-on experience, but we know about this one.
No worry. I'm just giving overview that if you guys sometime want to work on it, like I asked sir, that sir, it's a simple thing, the igniters. Else can I offer? So he said that the things that you guys did, you can tell them what it is. So this is my presentation for the final year project. So just a moment. You guys have learned about the open rocket, right?
Yes, sir. Yes, sir.
It's a great tool, yeah. This rocket that I am having over here, I've got the exact same proportions and calculations by getting those materials and all into feeding those material into it, and the calculations really work. I was really happy with the results. So this is what I was talking about. There's a ESP board that is known as Node MCU. You can like it has got its own code. You can see it on YouTube too, and you can code it to become a switch. Okay, just a turn on and turn off switch. You can get the code from the YouTube, and alongside that we have got a motor controller. It is also a like electronic part. So with the help of that we can control the current that we are supplying. Like over here it has got voltage outputs. So the voltage output we aspire to have, it can have a voltage output up to 15 volt. So we wanted nearly 9 volts. Okay, so what we did was we connected the ESP, then ESP to the motor controller, and ESP was connected to the batteries that we were having. Okay, the batteries were powering the ESP as well as the motor controller, and it would be giving the spark. Okay, then what? Then next, what we did was that we used these igniters and we connected this with the. Can you see the screws on the motor controller here?
Yes, sir.
These screws, we connected these wires, the lower ends of these wires with the screws. And afterwards, when we this node MCU, this ESP board is having the Bluetooth connectivity. We can control it from our phones.
Ah.
Okay. Did you guys know this earlier?
No, sir.
Okay. So this you can do at your homes or at your university when you go back to university, or if you find these electronic components here, you can do it here as well. But here you should learn about the rocket models first. Afterwards, you should go for this higher things like how to make this kind of igniters. Actually, I could have used simple ignition system, but the thing was that according to my uh, minor year project, so it was needed that I had to do it remotely because my launching site was nearly 15 to 16 feet higher than where I stood. So if I took that wire, understand one thing also, the length of the wire also affects the uh, power that you need to apply for the ignition. If your length is more, then your wire is also offering resistance, right? So if it is the length is more, we know that resistance is directly proportional to length of the conductor. So if the length is more, then we have to supply more power. So if we can, so it's better to use jumper wires or very thin wires for this, because it will go off for sure like a fuse. So I was explaining this that it was just a click of the hand, and the thing got launched. The igniter, it maybe it had a range of 20 feet. So within and it is really a good thing to do it. Like if you guys can develop this thing also, then it would be really okay for you, so that you guys don't burn your hands, because while igniting those circuits, you guys have no that igniter with you, that red color thing, the one that is having button on it, the launcher.
No, sir.
Okay. Over there we can see the one like factory made thing comes, and we have to install 6 batteries into it for, and those batteries are just overcoming the friction of the wire only, just giving very small current to igniter. So hope you guys understood what this is all about.
Yes, sir.
Any questions that you guys have?
Any question?
Anything regarding the rockets or anything that you want to talk?
Sir,
Yep.
sir, you said that we can use the ESP board and microcontroller for wireless ignition, right?
Yeah. Wireless ignition, right?
Sir, for ESP board, we need to give power, right, sir?
Yeah, right.
Which can be provided by the batteries, I think so, yes, sir.
Like what?
Batteries.
Yeah. ESP board has got pins for the ground and the live that you have would need to connect both the terminals.
Yes, sir. Where, in which place we have to place the batteries, sir. Fix the batteries inside the rocket or
Hmm?
inside the rocket. I think so. Yes.
Yeah, it's near the rocket only. The
Uh,
bat. Yeah, it would be this thing you can shield it with anything, because you just need to get the wire outside, right?
yes, sir.
Other things you can shield with anything. These ESP and other things.
Okay, sir.
Only these things are being near to the rocket so that you might be away from it. Okay. Yeah, it can be used for safety.
Okay, sir.
Like over here, when we did it, it was really hyped that people are launching their rockets from a distance. It really felt like we are launching some really commercial rocket, while it was just a small one, right? But these are the stepping stones for the bigger things, right?
Yes, sir.
So these are the innovations that you can come up with when you guys will be doing your final year projects. Like now in 7th semester, you guys will be doing a minor project, right?
Yes, sir.
Over there, you guys would be having many like uh, it's not always about drones and all. Like you guys are not in aeronautical, you guys in aerospace.
Yes, sir. Aerospace.
Okay, so you guys can go for the things that are related to space too. Okay, so I have always been fascinated with the space thing more. People over here might be were doing, most of them were doing drones and all, but it's drones and all is already developed and many things have been done. Over here, you should do something, some project that may include the electronics part, the computers part, and like a bunch of stuff coming together, so that you could be having a lot of stuff to feed your externals and all. Um, this ended up giving you the insight that how to get marks, because those externals really don't give marks. You really need to work on it. Just a moment. I'll try it once again if it. Are you guys having any igniters with you right now? Like any of any sort?
No, sir.
No. When you guys are planning to make these
Within today evening.
today? Okay. Burn, yeah. Maybe actually over here in Punjab, it's really misty over here. Like it's mist is coming on our face, like it's raining. So I'm sitting in a closed lab. Still, it is like the mattress is very mo- having a lot of moisture onto it. So maybe that would be the reason why it's not getting ignited. Or I'll be using another match. Just a moment. Over in this lab, we keep burning stuff. Yeah. Like the lab assistant is really fed up that we always keep creating mess over here. Anything other than that?
No, sir.
Any queries?
No, sir.
Okay. Keep an account of everything that you do. Okay. Just every inch that you guys utilize, every gram that you guys utilize, because that would be very beneficial for you guys to formulate your project reports. Okay.
Sir.
Start working on those too. Okay. So I'll try. Probably due to moisture, yeah, because it is not getting ignited because of the moisture. The batteries are charged, everything is okay. Still, how's the weather over there? While we were there, it was really like pleasant weather in August.
Yeah.
Is it cold over there?
Yes, I cold. Somewhat cold.
Cold. Okay. Is it like foggy, misty?
No,
Yes,
sir.
sir.
Hmm?
Yes, sir. Foggy.
Foggy. Okay. So you guys do keep this in mind because we did it in summers. So there might be a case that it would be giving us some problem here. I was testing it till yesterday. It was working well. I don't know what happened today. Like it happens in many of the presentations when we are having the main time. I'll see if I have the other battery that we use over there. If it's here, then we can. Are you guys having the battery that you guys are
What, sir? What, sir? Pardon, sir.
the battery that you guys are going to use that 9 volt battery? Are
Yes,
you
sir.
guys having it with you right now?
No, sir.
Can you show me?
No, sir.
Huh? Achha, you guys not. Achha, you guys can get it from any shop right over there.
Yes, sir. I will come.
You guys have seen that HW battery, that white and blue color battery, right?
Yes, sir.
Yeah, that would be fine. That would be giving you enough current and voltage for the ignition. Okay. So whenever you do so, let me know. Okay.
Okay, sir.
I'll be. Yes. So, oh, you guys are actually having that, huh? Seven. In the group. Keep posting it in the group, okay? I would like to see that what you guys made out of it, okay? whenever you'll be testing. So the process is clear. Are you guys? Is the process clear?
Yes, sir.
Yeah. Anything like now, the questions will only arise when you guys try to do it. Okay. So try to make it as soon as possible, then test it and make multiple of them. Okay.
Okay, sir.
Because yeah, because I know that when we were testing, then we tested 3 times and the igniter wasn't igniting. We don't know why it happened. And when we tried the fourth one actually fired because these are very having low precision. It's like almost and one more thing that's out of experience I can say you that when you guys would be putting the igniter into your rocket that motor, please once blow it. Okay,
Okay, sir.
blow air into the core. Okay, because while sitting over there it won't be having any oxidizer in it. If it is not having oxygen inside, then the combustion would be won't be that but good. And if the combustion is not there, then the rocket motor will not get ignited. Okay.
Yes, sir.
So okay, so maybe I'm clear with what I intended to say over here. Any questions if you guys are having anything regarding anything about the reports, or I can help you with that too. It's really amazing to see you guys working on these things.
Thank you, sir.
Thank you, sir.
Yeah, keep it up. I hope you guys would be making great projects, and whenever you do, let me know too. Okay,
Okay, sir.
Sure,
Sir.
sir.
you guys are having my number in uh, the group itself, so you guys can contact me like privately also, like in inbox. I would be really happy to help you guys. Okay.
Yes, sir.
Yeah. Any assistance, then you can call me too. So I'd be very, or you can just text me that where you are getting stuck or any problems that are arising. I can give you assistance with that only because this presentation alone would not be enough for the completion of the project. I know, right?
Yes, sir.
To collaborate with each other, use your minds, put them into great use. Whenever you like now, if you guys are, I know you now. You guys are not having any questions. I don't know why. Maybe lack of curiosity. And when you guys would be doing that thing, then you would be having a lot of questions,
Yeah, yes, sir.
right? It happens, right?
Yes,
Yeah,
sir.
yes, sir.
Yeah. And whenever that happens, and one of the other guys, Karandeep, right? I saw his number in your group, right? Are you guys familiar with him? Okay, okay. No worries. I might be mistaken. No worries. Okay, so maybe we can wind up with the session. Any questions and queries are welcomed. You can ask it now. You can ask it anytime. Okay.
Yes,
Okay,
sir.
okay, sir.
No questions.
Yes, yes, no question.
Okay. Ready to launch?
Sir. Yes, sir.
Just make a proper video, yeah. Okay. I just want that a proper video, like with the countdown that from 10 to 1 and then take off. Sorry, lift off. Okay, like the one that they do in Shar, right? You guys see those launches?
Yes, sir.
Anyone you do?
Yes, sir. Yes, sir.
It is very essential for you guys to be connected and be knowing about the launches that occur, like any space agency.
Yes, sir.
I'm the one that I'm not missing any of the launches. ISRO, it is very occasional, but SpaceX, it keeps on launching. Like you guys might be familiar with Starlink.
Yes, sir. Yes, sir.
Yeah, so they keep on stacking uh, those satellites and they keep on launching them into this orbit. So it is really good for you guys to see those launches because you will be learning a lot of stuff because that is the application. Okay,
Yes, sir. Yes, sir.
that is the only thing that would be giving you the insight and you will be having the edge over others. That being aerospace engineers, you guys would be knowing that what's actually happening in the industry. Got me? Got me?
Yes, sir.
Yes, sir.
Okay, so whenever any question arises, then you can text me. I would be very happy to help. So with this, I would be like very thankful for you guys to spare your time. Okay, for getting into this innovative thing. Okay. So with this, Mr. Bhubaneswar, is he there?
Yes, sir.
Yes, sir. Thank you for the session.
Yeah, sir. I hope I would be in these things would be helpful for the students.
Yes, sir.
Yeah. So, Mr. Bhubaneswar, can I leave now?
Yeah, sure, sure.
Okay. Thank you very much.
Thank you, sir.
Thank you, sir.